Good morning, friends. Today we are going to discuss next topic, that is our acid and bases and most important concept about PCB TSPSC Paper 2 Chemistry. Okay, without wasting time, we'll start the class. The most important and accurate questions and with answers and multiple choices, and I will give best explanation for you. Okay, without disturbing, we'll start the class. And don't forget to subscribe my channel and please follow for more details and more update about PCB TSPSC Chemistry exam. Okay, now you see here. Today we are going to discuss most important most important uh, acid ion bases. See this acid ion bases. Most important acid and bases acid and bases and in this subtopics are bronzed acids and Lewis acids and these theories acid basis theories and what is odd and soft acids and what is the HSAB theory. All these things we'll discuss with the framing of questions. Clear? So don't forget to subscribe my channel on YouTube, that is RGP25. Okay, at the rate RGP25. Okay, we'll start the class. See, first question here, first question here. According to Bronsted-Lowry theory, an acid is a substance that yes, what is an acid? Okay, I'll give you best example to understand this concept. So then we can understand what is the answer for this. Clear? For Bronsted acid-base theory, I am giving one best example. All of you concentrate here. See, I am taking here HCl, hydrochloric acid, plus and H2O, H2O. Clear? Now, gives rise. Actually, it is ionic equilibrium, reversible reaction. Clear? Acid-base reactions are ionic equilibrium. And see this. What happened here? HCl plus H2O. What happened? Here, HCl can donate one proton. One proton is H plus to water. Then what happened? It became as a Cl minus and H2O became as a H3O plus. H3O plus. Here some changes are occur. What are the changes? I will show you. See this. Here it is called proton donor. Proton means H plus. Proton donor it is. Donor. Proton donor. This is here proton acceptor. Proton acceptor. It is proton acceptor. One is proton donor, another one is proton acceptor. Clear, sir? So proton donor is generally called as what you know? Proton donor is generally called as, according to Bronsted-Lowry theory, proton is generally called as Cl, Bronsted acid, and acceptor is generally called as Bronsted base, BB. Clear? Now you can take a reversible reaction. It is again ready to donate proton to this H plus ion to this. Therefore, is also called here ready to donate now. So Bronsted acid ready to accept the proton to become as a HCl. Therefore, this is called a Bronsted base. So this is the major importance about here Bronsted acid base theory. Proton donor is called Bronsted acid. Proton acceptor is called a Bronsted base. So Bronsted theory is depend on proton. Therefore, this is also called proton theory. So now tell me, what is the acid according to Bronsted theory? That is our question. Now you tell me, what is an acid according to Bronsted theory? See the options: accepting of electrons, no. Donating of electron, no. Donating of proton, yes. Accepting of neutron. So here in this theory, Bronsted-Lowry theory, totally it is depend on only proton. Don't forget this. It is proton based theory, not belongs to electrons and neutrons, all these things. So bronzed acid theory is proton based theory. Proton, proton based theory. Based theory. Clear? What is the theory? BL theory. What is BL theory? Bronzed and Lorry theory. Clear, friend? You got the answer? Yes. So that is solution also given here. Brown-shade loss theory, proton donor who is act as a proton donor act as a acid, while proton acceptor is called as a base. That is brown-shade base. Clear, friend? Next question. Which of the following is a brown-shade base? See this. Just now take an example. I will go for one more example. See here, I am taking NH3 plus H2O, again water molecule. It is a reversible reaction. Here what happened? Tell me, anybody expect this? Comment. Yeah, here what happened? Here water molecule can donate proton to this, isn't it? Water molecule can donate proton to this. When water molecule donate proton to this, it is called here bronzed acid. This is called here bronzed base. What happened after this? Here NH4 plus is formed and OH minus is formed. NH4 plus is formed and OH minus is formed. Clear, friends? Therefore, here this is again ready to donate proton to this. Therefore, it is called bronzed acid. It is bronzed base. Here also proton based theory it is. Proton based theory. So now tell me which of the following is bronzed base in the given options. Tell me. HCl is what? Bronzed acid. Just now we seen. So this is not base. NH3 is what? Bronzed base. Just now we explained all these things. Clear? H2SO4 is an acid. HNO3, these two are also acid. Okay, these are your bronzed acids. I will explain clearly one by one. Clear? Now, see this. NH3 accepts the proton from NH4 plus and hence it is called bronzed base. Clear? So that is the meaning of. Next one. Which species is act as a Lewis acid? After bronzed theory, we'll go for your Lewis theory. This is second theory. Okay? Here, what is bronzed theory? What is Lewis theory? I will give just simple explanation to understand what is what. Clear? Clear. Now we'll go for your Bronzed-Lowry theory and Lewis theory. Both are I am taking here. So some differentiation we'll see. Here, Bronzed-Lowry theory based on protons, but here Lewis theory based on lone pair of electron, lone pairs, right? So, proton donor is called here bronzed acid. Proton acceptor is called bronzed base. But here donor lone pair donor is called Lewis base. And lone pair acceptor is called Lewis acid. Don't forget acceptor donor. Acceptor donor. There is some confusion. So your donor is called base. Your donor is called your acid. Your acceptor is called acid. Here acceptor is called base. But it is lone pair. Here is a H plus ion. Clear? So whenever some compounds like for example, see this BCl3. BCl3, CO2, SO2, such type of compound nature not explained by our BL theory because BCl3 do not contain proton, carbon dioxide do not contain proton, sulfur dioxide do not contain proton. Such type of compound nature not explained by our BL theory. BL theory not explained by this the compounds. So according to BL theory, we don't know nature of what is the nature of BCl3, what is the nature of CO2, what is the nature of SO2. Therefore, one more theory is introduced that is called what? Lewis theory. According to Lewis theory, we can explain these all things. Okay, we'll see. For example, here, see NH3 is there. NH3 contain lone pair of electron. So it is donor of lone pair of electron. See, donor of lone pair of electron is called what? Lewis base. Therefore, it is Lewis base. And OH minus also having lone pair of electron. It is also act as a Lewis base. And BF3, boron trifluoride. Similarly, boron trichloride. These two, boron trifluoride, boron trichloride, AlCl3. These are your third A group elements. Third A group elements. These are your Lewis acids, students. Friends, don't forget. So third A group element is mostly all halides of third A group elements are Lewis acids because they have incomplete octet. They require lone pair of electron. Therefore, they are accepting the lone pair of electron. Whenever any compound is accepting lone pair of electron, it is called according to Lewis theory, Lewis acids. Therefore, these all are Lewis acids. Now tell me what is the answer? BF3 is a Lewis acid. Cl minus also has lone pair of electron, you can donate. Therefore, your answer is BF3. BF3 is your answer. Clear, student? That's it. Next, which compound is Lewis base? Again, just now we discussed. Which Lewis base means? See, Lewis base means lone based on the lone pair. Lone pair, right? Lone pair. Donor is called Lewis base. Lone pair acceptor is called Lewis acid. Now tell me, which is Lewis base is asking. Which is Lewis base? Donor of lone pair of electron. It cannot donate, it cannot donate, it can accept, but it required, plus means required, therefore NH3 is a Lewis base. I will give one example to that to understand this. See here, I am taking here, for example, all of you concentrate. I am taking here NH3 plus H plus. See what happened between these two. Actually, this is a H plus. Here it has lone pair of electron. This lone pair of electron can be donated to H plus. What happened? NH4 plus is formed. NH4 plus means what is NH4 plus? Nitrogen with four hydrogens. But this is here covalent bond. This is here covalent bond. This is also covalent bond. But this is dative bond. Dative bond. That is called here coordinate covalent bond. So that is here dative bond. Any compound will give you dative bond means it donate lone pair of electron. So dative bond is formed by the donation of lone pair of electron to other compound. So that is nothing but arrow mark. Arrow mark indicate two electron, that is pair of electron. Any compound is donating pair of electron to this hydrogen, this pair of electron donating. Therefore, this is donor, this is acceptor. Therefore, NH3 is a Lewis base. Clear? That is the concept. Clear? Next one, we'll see. Fifth one, conjugate base of H2CO3. So before going to that, we need to understand what is a conjugate acid base. What is a conjugate acid base concept? So I will explain. All of you concentrate here. What is a conjugate acid base theory? In this, we have here conjugate acid base theory. Conjugate acid base theory. Clearly, I will explain. All of you concentrate here. Here, previous example I am taking. Previous example. See this? I am taking H2SO4. H2SO4 losing of one hydrogen, it becomes HSO4 minus. Again, it lose one more hydrogen, it became as a ESO4 minus 2. See, what is the relation here? What is the relation here? Concentrate all of you. What is the relation? It is the bronzed acid because donor of hydrogen, right? Donor of hydrogen. It is also, it is donor of hydrogen, clear? That is Lewis base. Again, it is reverse, you can take reverse. It became as a acceptor of lone pair of electron, proton. Therefore, it is called here bronzed base. Now, again, you can see the relation between these two. Here, it can donate H plus, but here reversibly it is accept and converted to this. Therefore, this is here bronzed base, and again it is bronzed acid. Bronzed acid. Now, HSO4 minus is act as a both. when compared to H2SO4 comma HSO4 minus. This is here bronzed acid. This is here bronzed base. When compared to HSO4 minus comma SO4 minus 2, you see it can donate. It has H plus. Therefore, this is called bronzed acid. This is called bronzed base. Clear? So we can compare these two. These two. What is the difference between these two? See, the difference is here two hydrogens are there. Here one hydrogen is there. So any two acid bases having one proton differentiate, that is called conjugate acid base pairs. Conjugate acid base pairs. What are conjugate acid base pair? Any two acid base contain one proton differentiate. That two are called conjugate acid base pair. So here you can see here one hydrogen, here no hydrogen. Therefore, difference is one proton, one proton. Therefore, these two pairs are called conjugate acid base pairs. Conjugate acid base pairs. Clear, student? Now is asking conjugate base of. What is conjugate base of? Actually, is asking base, but it is acid. So what we need to do? We need to take that one H2 CO3. This is asking conjugate base of, this means this is what, this is bonded acid. So how to get base? Removal of one hydrogen. Yes, remove one hydrogen from this. What will you get? HCO3 minus. So this is called here conjugate base of this acid. Clear? See, one proton differentiate and we can find easy. So what is logic to find this? Very, very easy. See this? If any time they are asking conjugate base of compound, just you can remove one hydrogen, we'll get the answer. Sometimes they are asking conjugate acid, add one hydrogen, we'll get the compound. For example, conjugate acid of this given. Now add one hydrogen, we'll get this one. Conjugate base of, remove one hydrogen, you get this. This is a simple logic to find the option. So your answer is HCO3 bicarbonate. Clear, student? That's it. Next one, which of the following is hard acid? This is also very, very important. Okay, all of you see this. I will remove this one to explain here for this space. Right? Yeah, all of you consider. Which of the following is a hard acid? Very important. Generally, we have some concept. See, here is written clearly. So, I will explain it. In this example, hard acid is H plus. How? Why not Ag plus? Why not Ag plus? Why not Hg plus 2? Why not palladium plus 2? Means, here we can go for here. Best solution is this. Hard acids are small and highly charged, second point, and less polarized. These 3 points very, very important. First one is hard acids means smaller size, highly charged, and less polarized. Less polarized. So that in this comparison, see small size. So Ag plus atomic number, 108, Hg also 80, palladium also more than that, 48 somewhat, hydrogen atomic number 1. Very small size it is. So small size and highly charged. So this is also plus 1. So you can see this is also plus 1. This is also plus 1. Compared to this big size, the charge is very, very comparison more for this one. Therefore, this is highly charged because and less polarized. So here metals are highly polarized when compared to non-metals. So here hydrogen is a non-metallic nature, but it has here sometimes lose of electron is a metallic nature. But as a compound is hydrogen is a non-metal, but has metallic nature. But remaining silver, mercury, these are metal. Therefore, they have high polarization. But here low polarization required. Therefore, it is hard acid is H plus. Clear, student? That is 3 points. Don't forget. First one is hard acid, small size. First one, small size. Okay, small size. First, second one, highly charged. Very, very important. Highly charged. Third one is less polarization. Less polarization. Less polarization. right? This is meaning of hard acid. Hard acid. Clear? Next, we'll go for which is considered soft base. Here, hard acid, soft base. See, exactly these concepts are exactly matched. See, similarly, we'll go for here. F minus is given, OH minus is, but here answer is soft base is I minus. How I minus? I will explain clearly. You can see. Same concept here. Soft bases are large, opposite to first point. Hard bases. Clear? Hard base, hard acid, soft base. Clear? Now, highly polarized. They less polarized. These are your what? Soft base. These 2 points are important. Clear? So soft base are large in size and highly polarized. You can take here fluorine atomic number 9. OH is it is oxygen atomic number 80. Iodine atomic number 53. Here H2 oxygen atomic number 8. So compared to this, iodine very large in size. That is okay. Next one, highly polarized. For example, you can take here sodium iodide, sodium fluoride. Here, this is sodium atomic number 11, sodium atomic number, this is 53, this is 9. This size is this much, this size is this much. This is common for both. Now tell me which bond will be breakdown fast makes? Yes, this is highly polarized. So that is your meaning of polarization. Therefore, it is soft to base. So soft to base required large size, highly polarized. That is 2 points are important. So clear. Next one, very important. HSAB was proposed by, so here it is a special theory is Pearson, given by Pearson is given by HSAB, right? Hard, soft, acid base theory. Hard, soft, acid base theory. Okay. See what is this? Pearson proposed hard, soft, acid base theory. Okay. That is Pearson. Next one. According to hard, soft, acid base theory, hard acids prefer to bind with. Yeah, just now we discussed. See, hard acids, hard acid prefer to bond with is asking. Hard acid. See, mostly we have hard acid prefer to bond with a hard basis. So here hard acid plus hard basis. This is a prefer to bind. Don't forget it. Very important. So your answer is hard basis. HA, HB. You can take here H is common. AB. So what is AB? Hard acid, hard base. Don't forget. This is the combination. See that. Hard acids strongly interact with the hard bases due to electrostatic attraction. Electrostatic force of attraction. Clear? Don't forget this one. Very important. Very important. Clear? Student? Hard acids, hard bases. Next one. Which pair represent the hard acid, hard base interaction? Given pairs, which pair will give you information about hard acid, hard base interaction? Very important. Just now we discussed H plus is what? Hard acid. F minus what? Hard base. Clear? So these two. H plus add more interaction. H plus F minus gives rise HF or not. More strong compound it is. Most electronegative element it is. Most electronegative element. Right? So these two are combined. So therefore H plus is a hard acid. F minus is a hard base. Hard base. Tell me what is I minus? Anybody? Just now we discussed. Just now. Clear? Yeah. See this? Yeah. What is this? Soft base. Don't forget. What is this? Soft base. I am giving one logic for you. Fluorine, chlorine, bromine, iodine. See. Now tell me. Here, this is what? Fluorine is what? Soft, hard base or soft base? Hard base. Now iodine is what? Soft, soft base. So, in a fluorine, seventh A group elements. So, acidity or basicity, hard to soft. That is hard base to soft base. So that is here order. We can write here fluorine is hard base, followed by chlorine, followed by bromine, followed by iodine. Size based on the size. Clear? So this is the correct order of hard base, hard base to soft base. Don't forget. Okay, these all are bases. Minus charge, no? These all are bases. Acid means H plus, like this, Ag plus. These all are acids. Yeah. Next question is, so that is your answer is what? Yeah. See, which of the following is not a Lewis acid? Very, very important. See, AlCl3 Lewis acid, right? Fe plus 3, FeCl3. This is also act as a Lewis acid, right? BF3 is also Lewis acid. Just now I informed you that. Third A group elements: boron, aluminium, gallium, indium, thallium. These are all 13th group elements are third A group elements. Aluminum is there, boron is there. So both are. So iron also Fe plus 3 is a Lewis acid. Don't forget. Lewis acid. Not a is acid. So NH3 is Lewis base. It is what? Lewis base. It can donate lone pair of electron. Clear? Donate the lone pair of electron. Next one. The interaction between just now I explained this one. Demonstration. So here, what is asking? The interaction between the reaction between H3 plus H plus is gives rise to NH4 plus. Demonstrate means what? It's a acid base or Lewis acid Lewis base interaction. This is donor, this is acceptor. So that is interaction between Lewis acid and Lewis base. So this is the answer. Simple. Next one. See here, H plus accept the lone pair of electron. NH3 donate the lone pair of electron and form coordinate covalent bond or dative bond. It is also called what? Dative bond. Dative bond. Clear? Next one. Which of the following among soft acids? Just now we discussed. Tell me what is soft. Here, all metals are given. All metals are given. So it should be three conditions. Already I informed you that. First one is soft acids are large in size, and more polarization, more polarization. So these conditions are there here. See, Al plus 3, when positive charge increases, size decreases. Don't forget this. Size decreases. Positive charge increases, size decreases. Clear? The Al plus 3 small size. Then Fe plus 3. Then in this two, H plus ion. Just now we discussed, no? H plus ion is what? Hard base or soft base? See this? Just now we discussed about H plus ion. All of you concentrate here. H plus ion, H plus ion, H plus ion. Yeah, where is H plus ion? Yeah. See, hard acid. Hard acid. Therefore, here, we'll go for here. H plus ion, hard acid. Now, is asking soft acid. Your answer is this. So, it should be soft acid, larger, more polarization. So, therefore, Cu plus you know answer. Clear, son? Which of the following acid-base theory involve the electron pair? Just now we discussed Lewis theory. Lewis theory. Arrhenius theory is also related to H plus and OH minus concept. If any compound contains H plus ions, that is acid. Any compound contain OH minus ions in aqueous solution, that is called base. So this is a simple concept about Arrhenius theory. Brownshirt theory, just now proton. Lewis theory, lone pair of electron. Lone pairs. Based on the lone pairs. Ionic theory is not there. Clear? So your answer is Lewis. Next, last question. Which of the following is the strongest Lewis acid? Very, very important. So that any any compound, electron deficiency, ready to accept the pair of electron. Any compound is ready to accept. That is very important. Ready to accept the protons. Any compound ready to accept the proton, that is called a strong acid. In this, NH3 donate the lone is also donate. It is also donate. It is donate. All can donate. But in this, just now I inform you that 38 group elements are electron deficient. Electron deficient compounds. Electron deficient compounds can form. In this first element is boron, aluminium, gallium, indium, thallium. So in this, more electron required compound is this. It do not contain d orbital. Therefore, it has here 1s2, 2s2, atomic number 5, 1s2, 2s2, 2p1, right? So atomic number 5. So therefore, it required here lone pair of electron to get the octet. So only 3 electrons are in the valency, right? So 3 electrons in valency, it reacts with the 3 hydrogen atoms. We'll get, for example, 3 chlorine atoms. 3 chlorine atoms. We'll get here 3 plus 3 is equal to 6 electrons. How many electrons? 6 electrons are there in a boron compound. For example, BCl3 also contains 6 electrons. BF3 also contains 6 electrons. So in order to get octet, we require here 2 electrons. In order to get octet, we require 2 electrons. These 2 electrons are taking in the form of lone pair. In the form of lone pair. Therefore, boron family, that is third A group elements required lone pair of electron. Therefore, first example is correct answer. Strongest Lewis acid. Clear, student? Yeah, that is. So some revision important also, Vicky. Quick revision for you. So what is bronzed acid? Proton donor. Okay, clear. All of you concentrate here. I'll explain clearly. I will remove this clearly. Yeah. See, this revision is very important for you in order to get some concept. First one, you see. First one, quick revision for us. Quick revision for us. All of you. Bronzed acid means proton donor. Bronzed base means proton acceptor. Lewis acid means electron pair acceptor. Electron pair. Lewis base means donor. Right. Hard acid means small size, high charge, less polarization. Don't forget this point. Compulsory question it is. And soft acid means large size, opposite, more polarization, less polarization. HSAB principle means common sense. Hard acids prefer to hard bases. Soft acids prefer to soft bases. Okay, that is simple concept today's class. Thank you very much. Don't forget to subscribe my channel. I will means I will prepare daily one video. I will complete total syllabus up to exam. Okay, thank you.